Good morning, everybody, and welcome to the second day of the seminar. And welcome to the second day of the seminar. Of sharing this first session of the morning, sharing this, which is dedicated to alumni of the Rose School. Which is dedicated to alumni of the Rose School. The first speaker is she will talk about digital innovation in emergency management. She will talk about digital innovation in emergency management.
Good morning. It's a privilege to be here and start. Good morning. It's a privilege to be here and start this today. I will briefly talk to you about innovation. Briefly talk to you about innovation in disaster. Contemporary disaster risk management is contemporary disaster risk management is inherent intensive study, technology-wise, and extensive study implementation have shown that these technologies are essential. Implementation have shown that these technologies are essential facilitators. Catastrophe resilience in order to reduce catastrophe resilience in order to reduce casualties, preserve livelihoods, and improve preparedness. If you think about the disaster risk management, if you think about disaster risk management interconnected steps, it foresees actions that are aimed at understanding context, actions that are aimed at understanding context, treat them and monitor risks. Technology plays a fundamental role in all these applications. Technology plays a fundamental role in all these applications. And today I will present you a brief overview of some of the projects in this field, particularly concerning projects in this field, and artificial drones, remote sensing, and artificial intelligence were developed. Drones are an enabling technology that is part of a strong enabling technology that is part of a strong in which there are multiple actors in such a complex supply chain, in such a complex supply chain the collaboration between developer, research, and experimental bodies to transform the applied research in solutions that are tested and functioning. EUCenter operates as a coordinator into networks in which the use of drone is fundamental in which the use of drone is fundamental for the first one. We are coordinator at the national level of the center of national level of the network of the center of competencies department, which has technical and scientific units that make fundamental use of drones and fundamental use of drones and develop services at more regional level. We are a coordinator with regional level, Region Lombardia, coordinator with for the Region Lombardia institution for the network between institution to medical up to county institution to medical, and also with regulatory and supervisory bodies, and also with regulatory and supervisory bodies in the civil aviation. These to define the roadmap for the use of drones in emergency. Why networks are so important? Why? Because of the added value that they brought, because of the added value that they brought, service value chain, they bring to the so-called service chain, which is integrated, limited to the single individual technological component, single individual technological component, the focus on the value chain, which collecting the focus on the value chain, which collecting the data is fundamental, with precision, thinking about fundamental, integration of different sources, thinking about processing, in this context, the cooperation, for this context, the cooperation, identification, for contributor requirement, homogenization of operating procedure, homogenization of operating procedure, for a service integrated operational coordination with national, which integrated operational coordination with national and the preparedness activities, facilitates the preparedness activities and effectiveness in. So let's start having a look on what we have developed in the recent years. Some of the technical services that we have developed for some of the technical services we have developed for the civil concern, for example, methodologies that are applicable in case of post-event. These methodologies have been successfully tested, and now the use of digital application, for example, allows us to perform 3D surveys, photogrammetry that allows us to create a digital twin of the structure that can create a digital twin of the structure that can be later used for final structural modeling or a simplified banana. All the data that are collected during the survey, especially on the damage conditions of heritage especially on the damage conditions can be accessed thanks to the use of virtual tools, in which all the information on damage patterns, all the information on damage patterns at a later stage to design, can be used at a later stage to design correctly such typology interventions for such typologies of structure. We also operate at a larger scale. We also operate when a survey of a large area is required. When a survey of a large area is required, for instance, photogrammetry methodology that PFTR developed in a limited amount of time to map large areas. This methodology is applicable in emergency context. Practical context and is based on practical experience, the coordination with the stakeholders, and of course, the coordination with the stakeholders, regulator was fundamental for its application. I'm showing you two brief examples on what we have done. For example, for example, the purpose of the exercise was the purpose of the exercise was retrieving a large area, concerning a large area, using two teams that were working in parallel, making a spatial with a spatial and temporal This allows us to produce not only orthophotos, but other instruments that identify areas that can be reached by first responders, identify areas that can be reached by first responders, evaluate safe areas in which coordinator see the accessible roads, or evaluate the values of the amount of volumes of debris. Also, the idea is to provide to the end user. Access the information in a very easy way. Also because the access to technology may not always be easy. Because the access to technology may not always be easy. Tools like pottery offer advantages. Great power of this advantage solution. Great power of this to share a point cloud solution is that it's possible to share a point cloud which measurements can be performed, so that the first responder can be performed immediate, especially of the critical operation areas. The second application was a large technical and thematic seismic exercise that took place in the autumn of 2023, in which all the participants were coming from 8 competence centers, and the exercise was designed and promoted by the network. In this case, 5 teams were working in parallel. We have surveyed a total area in a very limited amount of time. In a total mission time between 2.5 hours, maximum 3 hours, to produce the same type of product that you've seen before for the previous case. The total time for processing is about 2 amount of about 2 hours, but the amount of data is significant. What are then thinking about what we've done so far, what are the challenges with our experience in your center? What are the challenges limited, at least from my limited point of view? Of course, the team activation is an issue. Of course, the team activation is an issue. Of course, especially for us that are belonging to a center of competence, and not directly to the drone pilots. The team activation for drone pilots in operation areas still because of the regulation still something that needs to be discussed, still something that needs to be. We are proposing to the flight authorities scenarios in which team scenarios in which can provide support like us, can provide support law enforcement teams and to the law enforcement teams. And of course, the rationale for a coordinated drone-based survey is fundamental. Thinking about how data are fundamental in the development of innovation for emergency response. Their use is at the basis of the development of technologies, especially if we think about the implementation of algorithm that can support, for instance, damage assessment. In this case, UCenter has a huge archive of images images that were collected in the recent earthquake in Italy, 40,000 images, from which we have extracted a database in which approximately 5,000 images have approximated 5,000 images have annotated damage. This database has been used. This database in several projects that were funded from the European Commissions, whose objective was to help the first responders to have information that are essential to improve. For instance, the TeamAware project. Increase the safety of first responders area. Use drones to identify and determine the risks. In order to improve the crisis management, to improve the crisis and the reaction capability of first responders, through real-time, refine, and manage. This project was based on the use of artificial intelligence, augmented reality, and mobile human-machine interface. We have designed a tool that allows provide information on the structural conditions of buildings after an earthquake, particularly the occurrence of an earthquake. The methodology that we have implemented is a tool that is able to screen video that is able to screen video that is acquired from drones, and detect and extract information about damage on buildings. The system is integrated in the platform and allows to provide to the common center information on the structural safety of the structure. Essentially, this is the application of infrastructure monitoring system, assuming that we are in a monitoring scenario. We have provided guidance to the first responders how to perform the mission, how to prepare data giving, how to acquire data giving, how to perform information and instruction, how to perform a survey with the drones, giving, for instance, the data are then processed through user interface, and then the outcome comes in user interface, and then the outcome comes in a machine readable, so that a human tool is installed on ground station. If the tool is installed on ground station, it's present on site, the results are readily available. If not, if the presence of a structural aspect is present from remote, the data can be uploaded on the platform. From remote, the data can be uploaded on the platform. The information that are given, engineer can use the information that are given to perform a structural assessment and then provide information to the teams on site. Essentially, how this tool works. The damage detection module is based on the time in which we have developed it. At the time in which we have developed it, further developing it, using new architecture, constantly using new architecture. There are constantly. The output reporting model allows to clean and interpolate the information in order to extract a sort of damage lifeline. That is presented in an output in the form of a report that is then uploaded on the platform. Of course, the tool has been tested from the users that were involved on the project. It's still not perfect. The level of accuracy is still not perfect. The level of accuracy well performing, but this depends on how many data are used. Although we are using something like 25,000 images, we have tested it only on real images, and we have tested it only on real images, and still the accuracy work to do in order to reduce the number of false positives. Nevertheless, with an accuracy of more of approximately 70%, user for which we had positive tool for end user for which we had positive feedback. The integration of different sources of data, surveys, integration with point cloud generation from photogrammetry and artificial intelligence was also at the basis of artificial intelligence was also another project that was funded of another project named Drone for Safety. In this case, the focus was on the monitoring. In this case, the focus was on the monitoring and maintenance of coordinated teams of drones without coordinated teams of drones are supposed to perform autonomous flight recurrently are supposed to perform surveys to recurrently. In this case, surveys to inspect the structure. We have merged, in this case, the competencies on artificial intelligence with competencies on artificial photogrammetry in order to provide information. Photogrammetry in order to provide information directly on the cloud. On the state of damage of the structure. Are the challenges? Few are the challenges. Few of the challenges that are now in place with artificial intelligence. Of course, we need data that are sufficient for the training. Data that are sufficient for the training. We cannot think about algorithms. We cannot think about hundreds of algorithms that are trained with few hundreds of images assessment because these images are too few and too limited information for an algorithm and too limited information for an algorithm real-time applications, especially on real-time applications. Also, there is a need of crowdsourcing. Also, there is a need of crowdsourcing. Present sourcing. There are only few databases that are available. There are only few databases that are available to develop instruments that are efficient and to develop instruments that are efficient and applicable. Also, for the algorithm development, still algorithms are more focused on the still algorithms are more focused on the detection, whereas of a single field we need information. Whereas different on field we need information on different multi-class detection is essential. And multi-class detection is essential for responder to understand what is the situation. Also, depending on the typology of data that are using for depending on the typology of data that are using for training, performance of the algorithm, for the evaluation of the performance of the algorithm are not always efficient. If we think about the standard metrics for machine learning, think about the standard metrics for machine learning algorithms. These are focused on object detection. Damage is more an anomaly. Damage is more an anomaly, not performed properly. So the standard metrics cannot perform properly on a wall when we think about a crack on a wall. We may annotate it in different ways. Single box, we may annotate it in different ways. Single box, annotation it's influenced by the human factor. The annotation it's influenced by the human factor. Metrics that are able to evaluate the performance, metrics that are able to evaluate the performance of the algorithm, so prove the training of the algorithm, no matter how many boxes detect the damage. No matter how many boxes. There are also some drawbacks that we need to consider. There are also some drawbacks that we need to consider when developing artificial intelligence because of the level of high technology that is required, the level of high technology that is required, financial level of knowledge that is so for institutions that have not sufficient resources, to develop this as well as because of the high-level technical proficiency, because of there is a high-level technical proficiency, so there is even though we would wish to use it, so even though we would wish to use it in a certain way, implement it in a certain way, it's not always easy to find suitable to develop it, to find who is suitable. And also there are inherent biases, and also there are inherent biases and lack of generalization in the development. If we think about, for instance, our experience, if we think about the way, for instance, our experience depends on how the tool is homogeneously heterogeneous is the database that we use. Generally, if we think about multi-class damage detection, database that is used for training of the algorithm, database that is used for training of the as many images as possible, with as many images as possible, of all the classes of damages, for all the typologies of all the classes of damages, for all the typologies of a very great effort that is also a very great effort that is also financially demanding. In our case, as I was thinking before, this in our case, in order to evaluate better, in order to evaluate better. So creating new metrics. So creating new metrics. We are talking about in this specific. We are talking about algorithm in this specific case of algorithm that works with bounded boxes. With segmentation, it is a completely different story. If we look at innovation and use of digital innovation in emergency digital larger scale, in emergency and larger scale, satellite and remote sensing into something that we have been involved in a project at the regional level, partially project at the region of Lombardy, partially funded now the region of Lombardy, having a place now development in the new Iride constellation of satellite, in the new Iride constellation of satellite. The network project was meant to develop an infrastructure, develop an end-to-end service monitoring with integrated natural resource monitoring, with integrated use of satellite. Because we think that the integration of data coming from different sources is essential to provide first responder, is essential to provide meaningful responder and information that are meaningful, reliable, and accurate emergency reliable. Not always emergency management. The information not always satellite. The information is understandable are easily understandable. Also in this case, the level of technology, also in this case, the level of technology required to interpret that is required information that are coming from the satellite is not information that are coming from the satellite is not always available for the institution that actually working in emergency. In this case, the integration coming from monitoring are essential to validate monitoring that are coming essential to validate. I'm thinking about the data that are coming from radar sensors. I'm thinking about the data that are coming from radar sensors. We are easily drawn to understand the displacement in terms of evolution of displacement, but this is not the direct displacement of the point. But this is not the direct displacement. This is relative displacement of the point. This is the relative displacement of the satellite. This is not always understood of the satellite. This is not always understood by those who will use the information field or do not have the sufficient information to understand. Do not have the sufficient information to understand the meaning of these results. So these are some of the challenges that we see. For instance, for the user in Earth observation application in emergency. The challenge sometimes is also in the data collection. Because cloud coverage could determine that the satellite could determine that the satellite picture imagery capable to picture imagery. And then the information that could come from satellites is not available on time from satellites. It's not available on time. Also, it is fundamental to identify the requirements. To understand what the action need and use during the operations. In order to during the operations, in order to the value chain to provide structural services that are value chain to provide final products that are effectively. Also, the revisit and production times. Are observations at present. The satellite information that are coming may not always be the fastest with respect, for example, to other technologies such as even though this type of remote sensing, even though this type more costly, acquisition is more costly. And also the level of accuracy at present. Is not at a very high level with respect to what we actually with respect to what resolution of these images of precision. Also something that is very important for the use of data that are coming of data that are coming from validation observation is the. If we think about the definition of damage, there is currently. If we think about the definition of damage, there is currently used. For instance, in the Copernicus, the damage is related to the observation of the breeze on ground. From another natural point of view. But what is the actual level of structural damage? But what is the actual level of structural damage is not taken into consideration. Inherent way of looking of the satellite. Of looking of the satellite. For us, it is important to relate measures of damage to something that we understand essential to make a correlation between what is essential to make a correlation between what is the definition, for instance, with what is essentially seen by the satellite. the work that we are doing at present is the work that we are doing at present is to use the data that we have retrieved, feasibility assessment that were performed, usability assessment that were performed, to see whether we can make some sort of correlation, whether we can make some sort of correlation between the overall damage selected mechanism with those that are selected mechanism. Use these information to validate the use this information to validate the from years of preservation service value chain. From years of preservation. In conclusion, I think that it is important. In conclusion, I think that it is some issues, some challenges that are common, some issues, some challenges that are common to the especially the most innovative technologies, especially the most innovative. We need to think that the solution that we develop had a sort of trade-off. Solution that we developed had a sort of trade-off. Because of what I was saying before, not all the institutions have available taking care of emergency, have available financial resources. You think a very high-tech solution. You think a very high-tech costly instrument, very costly instruments to be maintained over time. Sometimes those institutions are not capable. Sometimes those institutions are not capable to use them if something breaks. So sometimes we need to think not just sometimes we need to think not just in terms of content of what we develop, but also in the content of what we develop, but also on the availability and accessibility of the technology. The technical limitation of who is going to use what we develop, who is going to use what we develop, as well as the creation of a technology, We are developing algorithms. We are developing algorithms very demanding. There are cloud services, but what if in emergency cloud services? But what if in emergency the Wi-Fi connection? Everything that we have produced is not usable. Everything that we have produced is not usable. To think about how we can also to think about in this sense how we can support them. Always sense to have communications always available. Data, as I was saying previously, is a critical. Data, as I was saying previously, is a critical quality. The timeliness, the access, and the relevance quality, timeliness. We need to discuss and to coordinate with the first responders. We need to discuss and to coordinate with the first responders in order to provide those information that are easily accessible, those information that are easily accessible, meaningful to make them effective, especially meaningful to make them effective. And also, something that we sometimes forget about, something that we have to identify sometimes forget about, is that we have to identify the legal, especially if we think about artificial intelligence, especially because we are responsible of the users of the data, because we are responsible of the users of the data, because they can have a direct impact on vulnerable groups. Sometimes forget about this. I think that we, as researchers and scientists, are sort of researchers and scientists in the notion of opportunities. The notion of we must be aware of our responsibility. We must be aware of our responsibility to work for a benefit of the community, not just for few. We need to work for a benefit of all, and not just for few. Thank you.
We have time for a quick question from the audience. We have time for a quick question from the audience.
I knew it was coming. I knew it was coming.
Ilaria, excellent presentation. Really impressive. Excellent presentation. I know Fabio is thinking the same thing that I am thinking. I know Fabio is thinking the same thing that I am thinking. Paula Pagliara to see this presentation. Paula Pagliara to see this presentation. Really very impressive work. Well done. Really very impressive work. Well done. Just very well explained. One curiosity on the thing on the issue. One curiosity on the thing on the issue of ethics of the use of the state, and in particular of the use of artificial intelligence. When you were mentioning these issues of ethics, because I think when you were mentioning these issues of ethics, thinking about responsibility or the fact that thinking about data needs to be the fact that sort of this data should not be misused. Protected should not be misused. And I want to touch it artificial intelligence is leading us to take wrong decisions. And so, how much that has been a discussion in the project, in the many projects involved in the projects, in the many projects, the chain of responsibility of when the chain of responsibility was actually made by an AI algorithm was actually made by a human. An AI algorithm and not by a human.
Especially when we were working on the TeamAware project, which was directly involved. The demand from the end user was something that tells me whether intelligence is something that tells me, and it was very hard to make them understand that this decision is not the artificial intelligence can support artificial intelligence. Can support us in a critical operation area. If you consider a critical operation hundreds of buildings that must be inspected, hundreds of buildings search and rescue operations are taking place, when search and rescue operations are taking place, to retrieve information for the first responders, to retrieve information for the first use of drones, and the use of these tools allow us to filter, the use of these tools allow us to filter, to provide assessment, but the assessment must be performed. It is essential. And also it is essential to understand how the instrument was developed, that our tool we are aware 100% that our tool is not, it is 100%, because it depends on the way that we are trained. It's like teaching half of the vocabulary to somebody and pretend he's speaking. We must be aware of this limitation.
Is there any other question? Is there any other question?
Thank you, Ilaria. Thank you, Ilaria. Congratulations for the excellent presentation. Congratulations for the excellent presentation.
Of course, it's a teamwork. It's not an individual work. It's a teamwork. It's not an individual work.
Doing it to this level of technology applied into this edge of technology applied to I must tell everybody, this job many years ago, when she was a PhD student, and she did this ground truth, she did this data ground truth, building by building. So this is something that building by building. So this is something that takes back on the edge of experience. So I have just a small question, and this is partly related to what Rui was saying before, and your answer was saying before. In the use of these and the development of these AI tools, we use data, area photogrammetry. Is there any involvement of the expert judgment? Humans that look at the pictures and identify cracking patterns, correspond to this damage. This cracking pattern correspond to this damage.
Yes, of course it is. Especially in the development of the database, especially in the development of the database. Those datasets are annotated by hand by structure using self-training algorithms to annotate burden resources, train resources, high-level train resources in order to provide meaningful and reliable. Of course, the trend is that the new algorithms but in this process there is always the presence of providing feedback, so that the self-training is providing feedback, so that the self-training mistakes, but it's self-training mistakes, but it's self-training. So this is something that we work on if we have the resources to do financially demanding. Still, it is financially demanding.
Thank you again, Ilaria, and congratulations for the work and congratulations for the work and for the presentation. I call now the second speaker, Dr. Annalisa Rosti. Talk about damage informed ground motion and observational fragility assessment.
Okay, good morning everyone. It's also a pleasure for me to be here today,
everyone.
and I will talk about damage-informed ground motion and observational fragility assessment.
Observational seismic fragility models rely on statistical processing of post-earthquake data, which are collected after past earthquakes. And for their calibrations, we actually need key ingredients. On one side, we need information on the observed seismic damage, for instance, on the residential buildings. And this information is retrievable and available from existing
On the other
side, we need to characterize the ground motion severity at the building sites, typically in the literature.
And
This is done
using the shape map
for getting information about the seismic intensity at the sites. However, it has to be observed that the shape map represents the median seismic intensity. So here we are referring to the 2009 L'Aquila seismic event. And on the left you can see the spatial distribution
on the left
of
you can
RC
see the
buildings,
spatial
which are considered as case buildings, which are considered as case study building typology. Whereas on the right you can see the shake map for the event under consideration in terms of median consideration in terms of median.
Once we have these two information,
we adapt
information,
models and fitting techniques
in order to
calibrate the observational fragility functions.
And these are the fragility curves
And
that
these
we
are the fragility
obtain
curves
when
that
we consider
we
the median
obtain
shake map
when we consider the median shake map
referring to the
seismic
case
input
study building typology.
referring to the case study
Here I'm
building
showing
typology.
as an example some of
Observational seismic fragility models that we
observational seismic fragility models
considering the median shake map,
in the past, referring to residential
Masonry building
referring
typologies,
to residential
and
residential
typologies
buildings
and residential RC buildings.
The fragility models that I have just shown, existing observational seismic fragility models that you can find in the literature have some limitations. The first issue is that we use consider the median shake map for seismic input characterization.
For
so
seismic
these
input
models
characterization,
neglect
so
the
these
shake map
models
uncertainty,
which is
neglect
due to the
the shake map
model,
uncertainty, which is due to the ground motion model,
spatial
correlation
the
model,
motion prediction equation
and
the
this
spatial
is not
correlation
consistent
model.
with the
And
principles
this is
of
not
probabilistic
consistent with the
analysis.
principles
Because
of
seismic
probabilistic
intensities at the
analysis.
sites are actually
Because
unknown.
seismic intensities
The
at the sites
exception
are
of
actually
few sites.
unknown.
Basically,
the exception
the
of
sites
where
few
we have the
sites.
recording
Basically,
as
the
the
sites
where we have the recording
there, basically,
the intensity
because
measure is
there,
known because it was
basically,
recorded
the intensity
during the
measure
event.
is known because it was recorded during the event.
So we are actually lucky because the model is known.
Implementation.
It is assumed that the log
implementation.
It is assumed that the logs
in the area affected by an earthquake
in the area
form a
affected by
Gaussian
an
random
earthquake.
field.
This
Form a
basically means
Gaussian
that
random
their
field.
joint
This
distribution
basically
is
means
specified.
that their
So
joint
the
distribution
stochastic
is
model of the
specified.
ground motion
So
intensity
the stochastic
in
model
the
of the
area
ground
is
motion
fully
intensity
specified
by
in
the
the
mean
area
vector
is
and by
fully
the covariance
specified
matrix,
by the mean
which
vector
accounts
and
for
by the
shake map
covariance
uncertainty
matrix
due to the
which
ground
accounts
motion
for
model,
shake map
so
uncertainty
basically due to
the
the ground motion
GMP
model
and
so
spatial correlation
basically
model,
due to the
and is
GMP
totally
and spatial
modified
correlation model,
in virtue of
and is totally
information
modified
provided
in
by the
virtue
recording
of
stations.
information provided by the recording stations.
So if we just refer to the median shake map,
if we
we are
just
just
refer
considering
to the
one
median
of the
shake map,
possible
we are
random
just
field
considering one
realizations.
of the possible random
And
field
if
realizations.
we don't consider
And
any other
if we
random
don't
field
consider
realizations,
any
we are
other
basically
random field
neglecting
realizations,
the
we are
fact that
basically
any other
neglecting
ground motion
the fact that
realization
any
would
other
result in a
ground motion
different
realization
estimate of the
would
fragility
result in a
parameters.
different estimate of the fragility
Now that
parameters.
we have recognized that
Now
shake map
that we
uncertainty
have recognized
has to be
that
properly
shake map
considered
uncertainty
in the
has to
calibration
be
of
properly
observational seismic
considered
fragility
in the calibration of
models,
observational
we also
seismic
have to point
fragility
it out
models.
that there is
We also
another
have to point it
second
out that there
equally
is
relevant
another
issue,
second
and
equally
this
relevant
aspect
issue,
concerns the fact that
this
damage
aspect concerns the
observations
fact
in
that
the area
damage
provide
observations
information
in
about
the area
the shaking
provide
intensity
information
in a
about
similar
the
manner
shaking intensity
as
in a similar manner as the
earthquake
characteristics
that is
and also
earthquake
recording
magnitude and
stations
locations
do.
And also
Let's see what
recording
it means.
stations do.
So imagine that we are considering S sites. Imagine that we are considering S sites. Of these sites, K are buildings. When the shaking intensity is unknown. When the shaking intensity the complementary number unknown. In this case, S minus the complementary number in this case S minus where the intensity measure is known because it was recorded during the Now this is basically our starting point. We know how to deal with this issue to account for. We know how to deal with this issue to account for basically the shake map uncertainty, but still we are not considering the maximum level of the available information. Also, because buildings, damage observations provide information about the ground shaking information about the ground shaking at the sites. Meaning that exceedance or not exceedance the exceedance or not exceedance of a predefined damage provides information about the fact that the ground shaking has been in order to cause the observed structural response. So this is because buildings work as simplified seismic stations, have to be considered in order to inform the shake map of the event under consideration. So basically, we will never neglect information provided by accelerometric provided by stations that are basically a few, provided by stations that are basically a few. At the same time, we cannot, for the same reason, we cannot neglect information which is provided by thousands of buildings. So thousands of damage between damage observations from buildings and recordings from buildings is that the information buildings provide is not in buildings provide is not in G units, but it's provided in terms of damage levels. But it's provided in terms of based on these considerations, we developed a methodology for calibrating accounting for the maximum level of the available information. Meaning that in the calibration, we account for shake map uncertainty we account for shake map uncertainty, we account for we account for oven distance, information from the recording stations, and this work was carried out in collaboration with the University of Naples, so Professors University of Naples, and Professors Iervolino and Giorgio, and Professor Penna from the University of Pavia, that I wish to So this is a starting point, and basically in order to calibrate observational fragility curves, we need to maximize these likely terms are pi, basically the probability of failure given the intensity measure, the probability of failure given the intensity measure, and we consider the logistic regression model could be actually adopted and considered, and the other key term is the joint distribution of the intensity measures, the joint distribution of the intensity measures to the building sites, conditional magnitude, conditional on measurements from recording stations. So as we said, basically this methodology accounts for all the available information. It is rigorous because there are no assumptions that we make concern characteristics. We are assuming that records from data are but actually we could also consider the source of uncertainty in our methodological framework. And we are also assuming that the observed damage is known because this is typically done in observational studies. Because this is typically done in observational studies. Also in this case, we could actually account for sources of uncertainty related to observed damage in
So the maximization of the likelihood function is actually challenging because we are dealing with thousands of buildings. And for this reason we implemented an iterative procedure relies on the expectation maximization algorithm based on sequential sampling.
Let's see some results. So here we see the fragility function for a preselected damage state that we obtain when we consider the median shake map for seismic input characterization. Continuous line refers to the fragility curve, which accounts for shake map uncertainty from the information from the recording station, and for the information from the recording station. Is the curve calibrated accounting for the maximum level of information. So the shake map uncertainty is constrained by the informative effect of the observed damage. We also wanted to investigate how damage informed ground motion, and here we can see a comparison between the shake map based on the left, whereas on the right you can see the damage informed shake map. Basically you see the shake map. Basically you see the PGA values the informative effect of damage. We also focused on buildings and specifically sites, distinguishing sites without damage, and at each site we evaluated the ratio between the damage-informed PGA from a shake map. And for each we computed the distribution of the ratio to the distribution of the blue one to the distribution without the blue one, whereas the red one refers to the sites whereas the red one refers to the two continuous lines are the median values of the distribution. The median values we can see that if we look at sites without damage, the ratio without the median value of the distribution is the median value of the distribution is basically 1. Whereas if we look at sites with damage, if we look at the median value of the ratio, we can see that the median value of the ratio is higher than 1. And this basically indicates that damage suggests the site were actually higher than those expected when this information is not accounted for. This information is not accounted for. I'm showing now the results that we obtained for all damage states ranging from DS1, all damage states ranging from DS5 corresponding to damage up to DS5 corresponding to collapse. Fragility functions obtained for the fragility functions obtained for the median shake map. Kind of, let's say, a sort of intermediate step, a kind of, let's say, a sort of intermediate function that you obtain when you consider a higher level of information, but still and basically these are the fragility functions, and basically these are the fragility functions when uncertainty account for whereas the red ones are those based on our EM procedures, so accounting for shake map EM procedures, so accounting for shake station and damage from the recording station and again, we did the same considerations, so with the same investigations that I've shown for so we referred to DS3, so we referred to something wrong. We consider sites without damage, and we consider sites without the ratio and we computed the damage-informed ground acceleration, the damage-informed ground acceleration, again the continuous line from shake map, again the median value of the ratio, and then we did the median value of the ratio, and then we did the same referring to the what we see that is that in all the cases, if you refer to all the cases, if you refer damage, if you look at sites the ratio is 1, the median value of the ratio is 1, if you look at the sites with damage, the median value of the ratio is always the median value of the ratio is always higher than the corresponding and higher than the corresponding case of the the corresponding one, no damage. You can also see that this effect tends to increase with the increase of the severity of going from DS1 up to DS5. So going from DS1 up to DS5. We also validated our methodology, and considered an ideal case simply considered an ideal case. We consider 50 sites selected from the damage database, and we placed 100 buildings at each of the 50 buildings at each of the 50 sites for a total of 5,000 we considered a known fragility model. So this is our assumed fragility. So this is our and we sampled 5,000 PGA values from the assumed PGA values from the assumed fragility model. Then we simulate a random field realization of PGA values, and this realization was considered the true intensity measures considered by the true intensity measures experienced by the buildings in earthquakes. Considering steps 1 and 2, we simulate damage data. You can see basically here you can see basically the simulated damage data as the ratio of the simulated damage data as the ratio of the damage buildings over the total buildings at the site. Applied the logistic regression on simulated data. Applied the logistic regression on simulated data because there could be an estimation uncertainty. And after that, we basically reapplied the procedures. So first, we evaluated the fragility curves. First, we evaluated the fragility median shake map for seismic input characterization. The median shake map, and then accounting for the shake map uncertainty. Finally, we applied our procedure to account for. We applied our procedure to account for, obviously, in all the cases we are referring to then we reapplied our procedure. Then we account for all the information available for all the information available. This is the curve. And so the red curve is the one that we obtain from the implementation of our algorithm. And you see that from the implementation of our algorithm. And you see that basically matches the logistic one fragility function that is the logistic one. In order to investigate how damaging we also computed some distributions. We also computed some distributions. So here I'm just showing the results for some sites because of time. And first you can see for deselected sites you can see for deselected sites the true IM that is represented by the dashed blue line. That is represented by the dashed blue line. Defined and evaluated the distribution. Evaluated the distribution which account for shake map uncertainty, which account for shake map uncertainty, and the dashed black line is the median shake map. So you can actually see that the median shake map. So you can actually see that the median shake map, with the exception of probably two cases, is quite far from, the true intensity measure. And in the end, we also evaluated the PGA distributions. First of all, you see how we can actually reduce the uncertainty on and also we evaluated the average value that is represented by the red dash because it's very, very close to the true intensity true intensity measure at the site. So in conclusions, most existing observational fragility models do not consider the models do not consider the uncertainty. We have said that this is not consistent with the principles of probabilistic analysis. Based on this consideration, we developed a maximum likelihood estimation procedure to account for all the information available. So basically the uncertainty in the shake map, earthquake uncertainty in the shake map, measurements of earthquake recording stations and measurements from the recording stations and damage observations, all damage states and all building typologies in principle. The approach is rigorous, but the direct maximization of the likelihood function is challenging from the likelihood function is challenging. This is why we basically consider expectation maximization algorithm. The main conclusion of this study is that the neglecting the shake map uncertainty neglecting the shake map implies bias in the resulting fragility parameters, and for this reason we should be more conscious and aware when we calibrate observational seismic fragility models because resulting have an impact on resulting that's all, and I really thank you for your attention. That's all, and I really thank you for your attention.
I found your presentation very clear. Lisa, I found your presentation very clear. I imagine there will be questions from the floor. I see two hands over there.
I just tried to act some sort of icebreaker. Excellent presentation. When Professor Volino first mentioned to me this work, we were having first mentioned to me this work in Rome, we were having University of Architecture in Rome, at University of Architecture. I thought Initially, I did not understand. I thought, then you explain it again. Initially, I did not understand. This is obvious. Then you explain it again. Why did we not think about this is obvious? But that's good ideas that they're always like that. But that's good ideas that they're always like that. They look obvious excellent once you see them. Really excellent work. Really enjoyed it. Really one question. I really enjoyed it in the presentation. Ideally, in an ideal world, we want to have shake maps. It's one of the most common uses of shake maps. One of the most common uses of shake scenario assessment is to do using the shake map scenario assessment released using the shake map that was USGS by 15 minutes after the event. Or USGS. In this case, 15 minutes after the event. So in this case, this is not possible. Do you imagine a future, given that we're talking about that in the previous presentation, given that we're talking about that in the future where do you imagine a future where use of satellite imagery and remote sensing collected data and artificial intelligence will be able to introduce this concept will be able to introduce this concept release shake map or fast thing that also shake map considering the computational intensity characteristics considering the computational intensity characteristics is not going to be used. This is always going to be something that is not going to be used for the immediate longer term aftermath of the earthquake, but for longer term type of analysis.
Thank you for your question. So yes, exactly.
Thank you for your question.
If we want to release shake map just after the earthquake, we cannot have immediately shake maps. We cannot have immediately shake maps with account also for first we need to let's say have first we need to let's say have after we have damage observations we can use the information we have damage observations we can use the information. So the first thing is that I think that. So the first thing is that updating the shake map for sure is still updating the shake map is still important. Also because the INGV does it after some time, following the first release. So for following the first release, these aspects should be considered. And then probably I think that in the future, and then probably I think that in the future with the improvement consider somehow to let's say consider somehow possibly let's say improve shake maps, but possibly improve the shake maps is something very challenging. Computational time I really hope so. Because as you see the results are let's say because as you see the results are let's say significantly different from what we would obtain.
Thank you, Annalisa, and congratulations. Thank you, Annalisa, and congratulations. Congratulating for the work, more or less. Congratulating for the work, more or less. Still, I know it, but I saw that there are some new things. I saw that there are some new things, so that need to be understood. One of the questions, one of the questions, as far as for your results, as far as for your results. Fragility curves that result from accounting for the uncertainty damaged and also based on the uncertainty of ground motion and based on the uncertainty of ground motion and look like flatter, especially for the highest damage, than the ones based on I was wondering. So I was wondering the largest damage. This is especially for the largest damage. So I was wondering if it is something that is foreseen by the method itself. That is foreseen by the method itself. That is accounting for these effects will lead to the black line, the red line stand, the black line, the red line stand, the median, typically below the fragility curves based on the median value. So I'm wondering if this is something that is foreseen with the method. Or it is something that may be related or it is something that may be related to some specific aspects of the case. Because all in all, it looks like all in all, resulting ground motion that will be higher, will be on average higher what is than what the median value. am I right? The median value.
Okay, thank you for the question. So about the fact that the ground shaking thank you for the question. So about the fact that the ground shaking don't account for damage higher than expected, we investigated the aspect by separating. We investigated the aspect by separating sites with damage, and you have damage from sites with damage, and you have these if you look at sites with damage. Whereas if you look at sites without damage, whereas if you look at sites without damage, which is damaging form, the peak ground acceleration which is damaging form is basically consistent when you're not considering that, let's say, when you're not considering that. Concerning the fragility functions, so if concerning the fragility functions, so understanding well you are referring to the red. I'm understanding well you are referring to the red. If you look at the median shake map, the median shake map is just one possible realization of the random field, and you're not considering any kind of uncertainty. So when you consider the uncertainty in the shake map, so when you consider the uncertainty in the shake map, you have an increase. So that's why the black dispersion. So that's why the black as a higher dispersion. But if you look at the parameters, the red curve, which is damaging, if you look at the parameters, the red curve, which is damaging form, because you actually account for additional information, because you actually account for additional information. So probably it's just like an effect of the plot. But if you look at the results, an effect of the plot. But if you look at the results, you see that there is the reduction in the dispersion value. And then in this case, we are considering a two-parameter model, but another one, again, if you consider this is the concept. Another one, so it's not something related to the algorithm, but it's something related to how the algorithm, but it's something related to how uncertainty, and then you add, let's say, damage uncertainty, and then you add damage information, which reduce the uncertainty due to the shake map.
Because actually you have shown in a previous map a map of values of PGA and compare them with the also the EQK, there were also the EQK, the recording station. The spot of high values was very large. I recall a map with high values, say 0.6 G, high values throughout a large portion of L'Aquila. Throughout a large portion I was wondering if this was a little bit against the records from the observation. So I'm wondering from the observation. So I'm wondering for that. I don't remember which slide is. I don't remember which slide is.
Okay. Wait, because this is the comparison. Okay, so actually with our procedure at the stations, the recording station returns the value that we use for the conditioning. So at the recording stations, if you don't have, let's say, buildings with damage observation that may inform the damage observation that may inform our procedure returns at that point the exact intensity measure recorded. The only difference, you have a higher PGA values here, but you have a higher PGA values here, but when you can see, it's better to look at this picture when you can see this area. So if you look, you have higher PGA values. You have higher PGA values corresponding to the size. This is not a final damage informed shake map. This is not a final damage informed shake map because we are just referring to for this, let's say, case application topology. In reality, you have to consider all damage states and all building topologies. But still, this is, I believe, this is consistent with what we are looking at.
Okay, thank you.
Question, just very quickly because we are running out of time. Just very quickly because we are running out.
Coffee break. Thank you.
Maybe it's better to postpone into the
During the coffee break.
It's better to postpone into the
During the coffee break.
Don't mind.
No, as you wish.
Okay. Thank you, Annalisa. Okay. Thank you, Annalisa. We'll move to the third presentation by Dr. Manuele about revisiting some numerical modeling concepts about revisiting some numerical modeling concepts for the assessment of precast pre-stressed hollow core slabs.
Thank you, Maria. Thank you for the introduction. Thank you, Maria. Thank you for the introduction. I'd like to start this presentation, just the last one before the coffee break. Just the last one before the coffee break in a very just with a very brief outline. Just with a very brief outline. So which is straight. Why? Which is not necessarily the why you could expect. Which is not necessarily the why you could expect. Then what? Which is actually what you could expect. Then what? Which is actually what you could expect. But more in the then and now and some closing remarks. Who and some closing remarks. So which one is the right topic to go for? Which one is the right topic maybe to go for? Project, maybe then a project, maybe so many testing efforts, the team, so many testing efforts, the team, which one? Community engagement, or maybe the project. So again, or maybe the project. So again, facility, project, again, facility. Again, so which one is the right one to go for? Which one is the right one to go for? In this case, we have some trapeze restraint installation tested components, and in this case, some components of a very peculiar structural elements, facade systems, facade, or maybe other purely theoretical or maybe other purely theoretical or maybe structural elements, or maybe progressive collapse of structure and structural assemblies, or maybe on this topic. So I got a bit confused, and before selecting I decided to go back to the original invitation, which roughly translated some invitation, which roughly translated for a piece of recent research, for a piece of recent research at the Rose that reflects, and I would leave in round parentheses what is, and I would leave in round parentheses. So I asked myself, okay, why don't you go back to the modeling? Okay, why don't you go back to the modeling? Topic, which is the one of the very first topic for my master thesis. So why don't we go for this 13 years old? So why don't we go for this 13 years old? Positive thing is that maybe positive thing is that your presentation done. You already have your presentation done. So it's just a matter of retraining it. Not only because of the format, not only because of the details, not only because of a couple of many details in this. They cannot find their way into a proper presentation. They cannot find their way into a proper presentation. I had to do the presentation. When I selected this topic, by wise people, listen. We have this kind of elements, and there are concerns. We have this kind of elements, and there are concerns. They were observed about their behavior. They were observed as loads much less than those predicted by codes. Loads much less than those predicted by codes. These people were right in the sense that here you can see in the sense that comparison of some comparison predicted analytically predicted for some capacity of these elements against some of these elements against data. The database consisted of 49 units tested by Pagari units tested by Pagari 6 nominal slab depth ranging from 6 nominal slab depth ranging from 200 to 5 different hollow shapes with different levels of circularity with different levels of or non-circularity in the voice, then different non-circularity in the voice. And as I was mentioning, here you have the comparison. Here you have the comparison of codified approaches, which is codified approaches, which is like EC2, European one, like EC8, as well as American Concrete Institute, as well as Canadian American Concrete Institute, and Canadian. You can see specific peculiar aspects related to depth, peculiar aspects related to red line is like perfect match. So the red line is like perfect match. So you have the prediction. versus the observation on the y-axis, so versus which one is over-predicting and which one is over-predicting and under-predicting. Then an overall comparison, and then finally an overall comparison, and finally an effect of which is something stress loss, which is for an element of consider for so we selected 9 units, which were modeled using units, which were modeled using brick elements, and we decided to go for brick elements and embedded line elements model with exponential and model with exponential and tensile and compressive behavior, the tensile and compressive behavior. Calibration of the fracture energy was according to model code, and we consider some sort of sensitivity to mesh, consider some sort of sensitivity to mesh. You can see also some examples of these. You can see also some examples of different 9 units which had different depths and different depths, and most representative smaller database representative of the entire one. We did simulation, and the models were pretty much the gray, in the sense that the green dots are the gray for the green dots are prediction for numerical prediction. You can see you can see showing the evolution, like contour map showing the evolution in one of these elements. So one of you can see shear failure pretty much clear. See shear failure pretty much clear. Just and showing just the same showing information, the same the shear stress information evolving with shear stress distribution evolving applied, the increased at different load applied levels at different along the levels of along the longitudinal axis. So this is reflected also by the principal tensile strains. You have two different units with different voice shapes, units more or less the same shapes, so you can more or less the same depth, very linear crack, very linear crack, more rounded one, and that is more rounded one related to the, and that is the shape related to the same comparison in terms of principal tensile strains, like overlap for the two units, like overlap for the two units in a specific point. So the crack pattern is also in line with what we were discussing before. And finally, some experimental observations. These experimental observations that these are not the elements that were tested by Pajari, but rather others that were tested by Pajari, but rather no crack pattern available. There was no crack pattern available. In this case, still you can see a clear difference. Still you can see a clear difference evolution of the crack, like evolution of the crack. These elements having completely different. These elements having completely different. So coming back to the distribution. So coming back to the distribution, there are discontinuities. You can note that there are discontinuities in correspondence to the pre-stress. These elements are these zones. These elements are disturbed, and these zones are very much disturbed by the fact that the force is not yet developed. And also another discontinuity, and also another discontinuity very edge part corresponds to very edge part. So you can also see that. So you can also see that form in and finally form. It is a comparison. And finally, it is a comparison of the against the normalized depth. Against the normalized depth, that is to have a different hollow course for different hollow course, and you can see that different elements, and you can see that tend to show a completely different distribution. So we decided to go and have a look at sort of corrective factor, which is meant to take into account this, which is meant to take into account this, and this is some sort of mathematical equation, trying to some sort of mathematical equation take into account this effect. Take into account this effect. Dimensionless parameters that are meant to take dimensionless parameter that are meant to take this into account. Comparison of the trend for the 9 units, which were those analyzed numerically, and which were those analyzed numerically, and the 49 ones. This coefficient was kind of working properly. You can see the comparison for different you can see the comparison for different and the gray line plus and minus 20% for plus and minus, and then also a comparison of the overall situation comparing the situation we made against the other we made against so we were pretty much happy at that time. Which is but then a brilliant PhD student took over brilliant PhD in the sense that following field observation of failure, during the Kaikoura earthquake. There were serious concern about the seismic performance of this typology is one of the most dominant flooring system used in the situation was more or less again the situation was more or less to academia asking for clarification. You can see clarification between university and other multi-year involved project. So the point was, we have a model, we can make use of it. We have a model, we can make use of it. Amount of experimental information available, was in the sense that not even a 40% comparison, not even a 40% comparison to be retrieved by the most updated by Bajari, which was the best one updated at that time. So we decided to go back to the lab, or to the lab and undertake some testing which were carried out at the University of Auckland. Here you have an example of the experimental setup, an example of the characteristics of the selected local unit. Selected is the most typical there, so at 200 millimeter there, so at 200 millimeter tip in between, with some sort of in between, non-circular, non-circular, white circular. You have the characteristics there just for and this the instrumentation, which is possibly the instrumentation for this kind of element, and overkill, and that is possibly also because of the experimental lack. Data, good experimental tests were almost an instrument. Tests were the one available, and with this kind of instrumentation, you can get not only clear for displacement response curve, but also clear for displacement response curve, but also other the strand slip and such as indication of the crack opening, indication of the deck by the sort of grid portal gauge. So here is a comparison of the six of the response. We decided to go for different. Shear span over depth ratios. Shear span over depth to see how the failure mechanism was sensitive to this kind of you have also a comparison of the overall displacement shape of the overall displacement shape pattern to be finally a good curve pattern, as well as plots providing the strand slip, in addition to the elongation of the crack pattern, in addition to the elongation of the bottom of the slab. With this, we also decided to go for some material characterization testing. So we decided to go for the best we could do at that time, the best we could do at that time of the hollow core, and go for the testing. You have an idea of the distribution coming out from which was used to calibrate the concepts and criteria were the same. The concepts and criteria were the same. In 10 years, we've just been able to know that. In 10 years, we've just been able to change the color of the. And finally, a comparison. And finally, a comparison that we have good comparison in the sense that we have levels, we have different levels. Shear displacement for this comparison, then a comparison of contour map, then a comparison of contour map providing stresses versus principal tensile stresses, traced from experimental and also the proper crack pattern, and also the principal tensile and the principal tensile. So in this case, just for one prediction, just the model was one prediction, but the model was all the other pretty much accurate for all the other experimental specimen tested. And in addition to that, you can also make use of this kind of data sensitivity analysis and obtain some tornado diagrams which tells essentially which is the most sensitive parameter or random variable for the response of this kind of somehow important, especially when they could accompany some fragility functions. They could accompany some fragility functions when you propagate some uncertain. Some cases when you propagate some uncertain physical meaning tends to get a little bit lost. So these kind of elements are kind of 200,000 to 300,000 for the numerical model. But still we decided to go for fragility analysis. To undertake some Monte Carlo simulation, assuming 100 elements, and considering kind of elements, and considering you have an idea of the random variable selected, as well as the variable selected, as well as the statistics we had for we decided to undertake so many analyses a model that is not an easy one to handle, I would say. Not an easy one to handle, I would say. Running analysis. And while waiting, we were asking, what about the torsional these kind of elements, and is this model able to predict torsion as well? Is this model able to predict torsion as well? We decided to undertake some analysis for the torsional case as well. We find out a good as well. We find out a testing case, which was for testing case, which was for pure torsion. Specimen were tested and analyzed numerically. Tested and analyzed numerically. Here, you can see the comparison. And the model is here, kind of quite accurate. And the model is kind of quite accurate. Overall response, which is no longer response, obviously, but rather torque versus displacement, obviously, but rather torque versus. And also in predicting the crack pattern. Luckily, you can see that the model is within. You can see that the model is experimentally within response, which is experimentally one response showing some sort of plateau before showing some sort of plateau before capacity drop, and the other one is showing capacity drop, and and the other one is showing slightly different posture. So the softening is quite different, that is reflected quite different crack pattern, but the model is pretty much different crack pattern, but the model is pretty much both okay in predicting and both overall. So we decided also to go for some sort of shear torsion interaction, sort of shear torsion for nominally equal specimens for tested, for nominally different specimens load configuration were selected by Pajari, by varying by varying, and here is the prediction. Even in this case, there was prediction. Even in this case, there was no what you can actually compare is just what you can actually compare is just by the actuator. You are applying by the comparison is kind of good in the sense that we are within 5 to 8%. We are within 5 to 8% mismatch. A comparison between what you can get numerically and what you can get numerically. I hope you can note this by the I hope you can note this by the orange ellipse. Red, you have concentration red that is very much in line with the one you have very much in line with the one you have observed, and then another comparison, and then another for another specimen which has another specimen which has different. We were pretty much okay with the validation. We were pretty much okay with the validation of this modeling concepts, and then we decided to go and analyze, and then we decided to go and analyze in this case you have the prediction. In this case you have the prediction. You can see the prediction done based on New Zealand based on New Zealand. It's not that accurate, especially if you go for especially if you go for analysis of data based on what data based on declared for their producer is declared. In addition to that, you can see that this model is able to predict the fact that the assumption of cross-section plane is no longer valid. Plane remaining plane is no longer valid. We were pretty much satisfied with torsional behavior. We were pretty much satisfied with torsional behavior, and were still running for the fragility thing. While waiting, we go for a part. So while waiting, we go for a part modeling concept. What if we make use of this modeling concept, the slab, but also not only the slab? So what about the sitting beam, for instance? So what about the you can see some characteristics? You can see some characteristics of the case, which is very typical case, which is New Zealand. Very typical. The rules were New Zealand. So the rules for the modeling were pretty much the same. The rules for the modeling were pretty much brick element in the sense we decided to go for brick elements kind of approach for the steel mesh topping. And again, you have an example of this kind of testing, experimental setup for this kind of testing. The testing was not as easy. The testing was not as easy as the one we have seen. So the comparison, the model is the comparison. The model is in predicting the response, which is predicting the response, which is like no longer a monotonic one model. And the extension of the criteria is kind of quite accurate in predicting both and the response and both crack pattern. The response and crack pattern. At different steps of the numerical response. And finally another comparison. And finally another comparison mechanism, which is for the model failure mechanism, which is negative. The model is able to capture the negative moment failure. There is some sort of mismatch. There is some sort of see the pointer, but that could be attributed to the pointer, but that could be attributed. So you have a crack in here, so you have a crack which is here, not what you can get from the numerical model. Not what you can get from the numerical model. We should have worked a little more for the reloading branch. Still, we decided to make use of the same. Still, we decided to make use of the same trying to predict concepts for trying to predict similar specimen with longer starter rebars. Similar specimen which is longer starter rebars. Maybe you go which is to say positive maybe you go for and the model is able to moment failure and the model is able to capture that as well. So 1 year later, and I'm not joking, so 1 year later, and I'm not joking, but 1 year to go for that. After all analysis, we adjust to identify limit state properly, we identify limit state properly, we want an initial flexural, diagonal shear crack, and diagonal shear crack, and then a fully propagated shear crack, a fully propagated formulation according to Porter, and here are the fragility function, and here are the this kind of function we derived for this kind of consider as EDP shear strength and EDP shear strength, and you have also another we have some sort of confidence test to see if some sort of confidence test to see if the data were kind of distribution we assume and they were distribution we assume and after all these we decided to go for some sort of simplified approaches. So the idea was to try to reduce the number of analyses reduce the number of analysis function by using extreme value distribution, by using extreme value distribution, and the most significant fragility are for sure different. For the kind of application, for the kind of application and type of uncertainties that there can be they are not so different. There can be they are not. I'd like to close with just fragility, which is the one you are not fragility, which is for shear the one you are not just because you have shear strength, just because you have and that residual could be something good to know the residual capacity, good to know the residual capacity you have pending in the element, maybe after also the comparison and the three different also the comparison again to say that the three different approaches, not so much again to say that. Then time to give credit. Then time to give credit. You can see beautiful picture. You can see the brilliant pitch. Beautiful picture of the brilliant pitch. All this simulation. All this simulation successfully defended. She's now a design engineer in Vancouver. She's now a design engineer in Vancouver. And yes, Pinker. Some closing remarks. Again, pretty straight. Some closing remarks for coffee break. Again, pretty straight. Is this earthquake engineering? Yes. Is this earthquake engineering? Yes. Are these models useful and usable? Are these models useful and usable? Again, yes. Pretty straight. I think they are. Yes. And finally, the two pending W's, which is to say Pavia back in 2011, back in 2011, and Christchurch and Auckland, which is where Pavia and Christchurch and Auckland, which is where starting in 2000 actually undertaken, starting in 2019. So, before getting to the end, just a list of references. If you are interested in getting more presentations to convey, and especially the red highlighted one, especially the red highlighted top 10 download paper, sort of top 10 download paper, which is something maybe good for Anna, which is something maybe good for Anna to have before entering the industry. And I'm done.
Thank you, Nigel. We are 5 minutes late. So we are on time. 5 minutes late. So I would say we are on time. So anyone has questions?
I see it's coffee break versus. I see it's coffee break versus question.
Thank you, Emanuele. Is it working? Thank you, Emanuele. Is it working? Excellent as usual, as expected. Excellent as usual. From the last slide, it is clear we have collaborated and working on many lesser known and common topics. Lesser known core common ceiling, core cabinet, ceiling, tank, silo, cabinet, and tank area topic and not area topic that are not wide. You started with a slide from the inspires you. You started with a slide that inspires these. I can say that
despite this, I can say that our among probably the most considered and cited researches on this. What is researches on this? What is let's say the significance focusing on topics focusing on no one else is working on, no one else is working on, and in which way we can inspire students, because derivation of fragility function is kind of stuff, but structure and civil engineering need to work on structure and civil engineering to work on. It's more philosophical. You are a very it's more philosophical, but you are a very intellectual man.
Very interesting question. I feel that very interesting question. I feel much dependent on the point of view. Very much dependent on that point of view. In the sense that maybe you are on the other side of the river, maybe you are on the other side of the river, or maybe you are just taking something that others not doing, and do something that others not doing. And this is where you can build some skill. And this is where you can build some skill. And this is where you can skill. Because at some point people could come to you and say, I'm not able to do that. Come to you and say, I'm not able to do that. And it is where you have the passing of passing of knowledge, and possibly where you can by the way, no PhD student has been mistreated for that work, but the mistreated for that work, but the one interested was in doing the one interested in doing. So when I proposed the fragility thing, when I proposed the fragility thing, was that idea is bad. Bad idea. So the idea is good. We go. But the idea is good. That is an overkill, a clear overkill. That is an overkill, a clear overkill. That is the thing. We go.
Grazie Emanuele.
That is the thing.
Strange for me to call you Emanuele, but anyway. Thank you, Bruno. For me to call you Emanuele, but anyway. Thank you, Bruno.
And by the way, David is here. Who is in New Center? Who is in New Center then?
Should we go for the coffee break? Is there any other question? Should we go for the coffee break? Is there any other question? I close the session. If not, I close the session. I congratulate Emanuele. And the coffee break will be served downstairs.
la metto? C'è una chiavetta? Caffè? Com'è che la metto? C'è una chiavetta?
Ok. Si sente? Sì. Ok. Si sente? Sì.
Ma perché sono due? Fa stereo. Ma perché sono due? Fa stereo.
We will start 15 to 12. We will start 15 to 12. Few other guys that are still waiting for their coffee. Other guys that are still waiting for their coffee. Okay, we can start. I'm Alessandro Reali from the University of Pavia. I'm not really from the University of Pavia. I'm not really of the field, but I'm very happy to be here since one of my first presentations, something like 20 years ago. First presentation, something like 20 years ago. Rosa alumnus. Because so let me start with this session, and let me start with this session. And first talk, I was asked to introduce the speaker. I was asked his name is Graziotti. His name is Graziotti. Understand immediately, and you can understand immediately. Why? Looking at the title is the title is Masonry. Shaken, not stirred, masonry. Shaken, not stirred, we are eager to learn the difference between Martini and masonry. The difference between Martini and masonry. I'm sure that stage is yours.
Good morning, everyone.
Stage is
Sorry
yours.
about the title. Good morning, everyone. Sorry about the title. Since we are at the Nigel Priestley seminar, why not starting Nigel Priestley seminar? Why not pioneering study by Nigel? That in 1985 wrote that in response of an masonry wrote that the response of an excitation is one of the most complex seismic excitation is one of the most complex and ill-understood areas of seismic analysis. I am confirming this, but it's not only the confirming this, but also one of the most vulnerable. Also one of the mechanisms that could happen in masonry. Consider that at least in masonry, consider that picture with blue sky were taken just in a picture with blue sky were taken just in working in Visso, Central Italy after working in Visso, Central Italy event of 2016. As you see, they are generally at the upper low overburden pressure that is reducing the low overburden pressure that is reducing this type of walls, the capacity as well as these type of walls, as well as structure tends to filter increase the acceleration tends to increase the acceleration with familiar also this concept were very Nigel familiar also to Nigel in 85. After almost 30 years, in particular in 2012 and 13, someone was still concerned about this is not New Zealand. This is, as you see, from New Zealand. this is, as you see, the windmill. It is looking at the windmill. It is basically in northeast of the Netherlands, basically in the middle northeast of the Netherlands, in the middle of let's say the countryside. I want to say nowhere, this is the place of countryside. This is the place of this place of 2012. This place in 2012, magnitude 3.6 earthquake was recorded. Magnitude 3.6, less than 0.1 G. And I know that less than 0.1 G are thinking, and I know that most of you is a bus passing by my house. The problem is that this becomes from the political and economic point of view, since this political and economic point of view, since this is induced by the gas human-induced earthquake. In fact, the Groningen gas field, when discovered in 1959, was the gas field in the world, largest gas and today is still the largest gas field in Europe, and the largest gas field in Europe, and one of the 10th gas fields in the world. Basically, from 1991, these tremors began to happen. And with the maximum level of magnitude recorded in 2012 with this using. As you see, the environment, the panorama was very quiet. A couple of news. Groningen hit by a new earthquake. I thought everything was collapsing. I thought everything was collapsing. And then you read better and say an earthquake measuring 2.6. Earthquake measuring 2.6 magnitude. Earthquake measuring 2.6 magnitude causing any collapse. But this is in this very quiet and relaxed panorama, and in this very quiet and relaxed solution, brilliant solution as this one, and also have a room. And please remember me to this type of thing. So in this context, the center was involved in a project aimed at assess the vulnerability to industrial buildings. There was at that time important lack of knowledge in resulted to be very important in, for example, the effect of low magnitude. For example, the effect of low magnitude, the seismic behavior of this peculiar structure, the seismic behavior very slender cavity walls, very slender cavity walls, and structure that was never exposed to the excitation expected studying of the area. Also detailing mechanical properties of the building stock was known, and of the building stock in general, since the hazard risk assessment at the study objective individual risks, so the loss of human life, also the collapse, so the loss of human life, also the collapse, this type of mechanism were very important. Something that in literature there was missing. One may think, okay, can address these. As we see also presentation of Emanuele, we can see these presentation of Emanuele, we can see laboratory test or laboratory test numerical analysis. But let me numerical analysis. But let me tell you this story. In 2013, I was in 2013 I was Professor Mike Griffith from Adelaide, came here. Mike Griffith from Adelaide to teach class. Came here with my teaching class with Professor Guido, and we were looking at a test by. And we were looking at it, probably it was a test by something on sheet table, probably it was a test on and we were at the window and we were at the center, and he told me, Kiko, you have to, and he told me, tell you something really important about numerical analysis, tell you something really important about numerical analysis. Me, recently graduated, this guy came from Adelaide to tell me this. Came from Adelaide to tell me this. Nobody trusts numerical analysis. Nobody trusts numerical analysis who conducts them, while everyone conducts them experimental test, while everyone believes in experimental test. And this is super true. And this is super true. That actually the genius was not the genius was not him himself. It was one of the pioneer. It was one of the pioneer in using computer solving engineering problem in Australia after the Second World War. So it is really after the Second World War. So I mean, in this context, you really understand that. I mean, in this context, you really understand that this phrase is really nice. So there is nothing to choose. We need really both of them. So there is nothing. They are absolutely complementary. Both of them. They are absolutely complementary. In 2014, he started this experimental campaign that actually started for this 5 years. Campaign that turned out to be 5 years. One turned out to be one extensive experimental campaign ever conducted, especially for measuring especially consider that we tested more than 500. Consider that we tested more than 500 in situ, 10 in plane quasi-static test, 10 in plane quasi-static test, so the steered one, 15 out of plane collapse, 15 out of plane collapse of roof structure, and 9 full-scale roof structure, and 9 full-scale UNM, 2 of center and LNEC, 2 of center and LNEC. So how we use this experimental data to assist experimental data to assist basically the development of this hazard and risk. First of all, the first thing was identify the vulnerabilities of it. The first thing was identify the vulnerabilities of it before the structure. We thought something before the experiment, and we are thinking something else now. Experiment, and we are thinking something else now. So supporting the calibration of numerical model to supporting the calibration of numerical model to support the development of exposure database, support the development of exposure database with the in-situ support the development of consequence model, support the development of consequence model with LNEC, collapse test, and publish and give access to all the to allow all the data. This was very important also to allow to collaborate. But I want to university to show you today is how we took advantage. Show you today is how we took advantage with how we took advantage of an industry-funded project to make step forward in different. This was a well-funded project. To be honest, and this was a well-funded project. And Rui is laughing. And research, I mean, beyond the mere scope of research, I mean, beyond the mere scope. First of all, in my opinion, we improve a lot. First of all, in my opinion, we improve a lot the testing method and data sharing. We developed simplified numerical models. Detailed numerical models. We calibrated detailed numerical models. Validate analytical formulation. Validate analytical formulation, guidelines, was very useful to propose studying guidelines studying new retrofit. So this is a picture of the first. Full-scale specimen. The first full-scale specimen that on shake table. As you see, the wall. As you see, the wall that is the wall. I mean, the wall load-bearing wall is as load-bearing wall. Famous album by Jethro Tull, as the famous album by Jethro Tull, you can imagine how it's to construct. Don't think about testing, but construct 3 meter high of house with a 3 meter high of interstory 10 centimeter thick. It was really 10 centimeter thick wall. It was by the way, the title is not completely out of. By the way, the title is not completely out of any. Because when at the beginning of the project we were to decide which how to decide which first one. How we were collaborated a lot with Aaron. Another alumnus. We were collaborated a lot with Aaron, Michele Palmieri actually. Michele Palmieri in Aaron. And we were looking at the various terrace house. And we were looking at the various terrace house present. It's called the one that they chose. It's called. So basically, we tested a Martini house. So basically, we tested a Martini house shaken, not steel. This super slenderness of the wall actually pushed us to try as the first attempt the out-of-plane behavior of this wall. The out-of-plane behavior of this wall. Nigel, this is when you are dealing with this type of wall. So we gained really reliable data. And with the focus on this type of test, clear boundary conditions, having clear input conditions, clear for example, clear input, overboard and clear in this case, for example, also overboard any variation in this case can be easily done. Any variation numeric can be easily done. The phenomena numeric once the problem are well known. Phenomena and with the problem are well known. Can actually and with any variation you can. But having a reliable data from the beginning is very. Consider that. Consider that, especially the one in one-way bending, so the most especially the one in one-way bending, so the most vulnerable one, because basically damping in this type of mechanism is governed by the mechanism between the rigid block and the ground, between the rigid block and the ground, and this is a function of velocity between the two blocks. And this is a function of velocity. Is exactly as testing. So you need a dynamic damper. So you need. This is not true for all the cases. For example, this is not true for all the cases. Cyclic test may be very helpful. Cyclic test may be very by the way, we discovered that Nigel Priestley copied. Discovered that actually Nigel Priestley copied in 1979 our setup. In 1979, that Pink Floyd. I don't know if it is a case that Pink Floyd is here. The wall and just to tell you that we did not invent. To tell you that we did not invent anything about. We spend a lot of time. We invest. We spend a lot of time in modeling the out-of-plane, not only the one-way modeling the out-of-plane, not only the one-way bending, and dynamic behavior, and developing tools that are really effective in risk general vulnerability. What about full-scale testing of buildings? What about full-scale testing? We test 9 of them in 10 years. I told you, we test 9 of them in 10 years. Meanwhile, 10 to be honest, because in the meanwhile, how and when, in 2017 we tested also a 100-ton four-story building, 100-ton four-story building, in a framework of a project aimed at assessing the vulnerability of the city. Project aimed at assessing the vulnerability of the test the 10 in basically test the 10 in 4 years. So what it important in my opinion here to understand is that it's important in my opinion we actually make a virtue out of necessity. Make a virtue out of necessity that for some reason NAM this sense that for some reason NAM wanted to have the report right after the first test. The report right after the first test. Some because they have some and we had I don't remember if. And we had, I don't remember if or 2 weeks, nothing. 10 days or 2 weeks, nothing. So for this reason, we decided to direct monitor never done before the displacement of the center because it was never done before in the center because before we double integrated the acceleration, with all the and also this is acceleration. Also very important. And also prepare all the architecture. Also very important. We prepare all the architecture and the report before the test. This was not the report before the test. This was but in this way, it turned out that this was incredible. But in this way, it turned out that this was basically during the test, because basically monitor during the test, we could monitor the evolution of the test, and this allows us to push really the limits. And this allows us to push really the limits in controlling the test, because we had all the basically controlling the test. Because we had all the basically during and plot that we needed during and. Okay, I will jump quickly on the representativeness of this building. Look at the detail. This is Stelios. Look at the detail of the roof. Look at the detail of the roof. Maniacal detailing. A lot of material characterization. We will come back. A lot of material characterization. We will come back on it. And instruments, sort of live elaboration data allow us to really push the limit. Live elaboration data allow us to really push the limit. For example, this is a collapse test. performed in LNEC chimney, and this is another test where we actually did the chimney, and this is another test where we actually didn't understand behavior. We didn't expect anything about this test, and behavior. We didn't expect anything about this test, and we actually had a full collapse of I don't know why it was standing after the I don't know why it was standing after the sometimes usually when something happens unexpected usually when something happens unexpected this is a good news for research. There is something new to understand. In this case, there is something the uplift of in this case in plane was the uplift of walls that actually in plane in air gap and walls that actually completely changed the boundary condition of the out of plane completely changed the boundary condition of the out of plane wall leading to collapse. The number of testers allowed us to statistical distribution. I perfectly understand that 10 is not a distribution. I perfectly understand that 10 is not a statistical representative number. But at least an idea of the variability of an idea of the variability of identify the limit state. Data, for example, very important. Identify the limit state. This is very important performing a risk study as one that was conducted. Performing a risk. We also try to test in the test, so dividing to the house in the test, so dividing structures and studying structures, the roof or the studying the west side, just the roof, or sometimes the side, the west side, and we had the chance also to test the qualitative behavior of the chance also to test the qualitative behavior of instructional elements, as you see here. IKEA cheap Billy furniture, IKEA cheap Billy furniture is sustaining the wall and really changed the crack pattern. But also from the quantitative point of view. But also from the quantitative point of view. Nothing was a study on chimneys. Nothing was about chimney. Nothing quantitative. And this is nothing quantitative. And this is a study on this type of elements. This work, so the use of macro element for the dynamic macro element for the dynamic representation of near dynamic representation of Masonry building was a work already begun much before NAMI project, but it was really fine-tuned project. And this is an example. I had another story about that. This is an example. I had another story about that. But just consider that this is just consider that this is a blind prediction. Is not really blind. Prediction is not really blind. Not finely tuned. Prediction is not finely tuned. 4,000 tons monitor buildings. 4,000 tons monitor buildings just to the Central Italy to the Central Italy. Detailed numerical models. I see that fortunately there is also detailed numerical models. Andreotti today, so we use also very refined numerical models. Very refined numerical models. For example, in this case, propose step-by-step guidelines. Propose step-by-step guidelines for some in-situ tests with these numerical analysis and with these numerical understood what's going on and understood what's going on and propose procedure interpretation. From the mechanical point of view, this model was also very useful because we noticed that torsional strength of Masonry, especially for the torsional strength of parameter governing actually the parameter governing capacity into a bending, especially when you are capacity into a bending, strong, especially when brick and regime mortar, strong brick and in some cases, especially where you had some sand, especially where you had the sand torsional strength was higher torsional strength than the theoretical upper bound of this strength. So that considered basically a plastic, fully plastic distribution of strength. This is due to the fact that the dilatancy tends to expand more. The joint tends to expand away from the joint. Okay. So basically you create a non-homogeneous compression field with a higher compression field with a higher stress far away from the where the lever arm is far away from the where the lever arm increasing the in some cases increasing the in some cases when there is this dilatancy increasing the self-restrained dilation, torsional strength for a sort of self-restrained dilation. We also had the chance to do we also had the chance to very peculiar in my opinion to test three nominally identical nominally identical on shake table. One subjected to just one shake table motion, the other one subjected to just 2D motions of motion, the other one vertical, and the other one subjected to horizontal and vertical, and the other one basically 3 of the 6 degrees of freedom. So using basically 3 of the 6 degrees of freedom of the center. What we discover is that at least for the type of what we discover is that at least for the type of looking at structure that we are the effect of vertical ground motion, the effect of vertical ground motion is similar failure modes, a non-systematic influence of vertical acceleration, a non-systematic influence of vertical acceleration, a more significant influence of the second, by far a more significant influence of the second horizontal acceleration. These both for this global behavior, both for the global behavior, but also for the local mechanism, the vertical motion. Really seems that. But again, this was just one test. But again, this was just one test, one test, 3 tests, one experiment. So, in reality, to see the real influence, you have to calibrate and run analysis, really different motions. And what we discover is that different motions. And what we discover is that in reality, there is an influence in reality, but there is within the range of variability of many other factors. Within the range of variability of many other factors, trend was trend was. We had the chance also to think about, to develop, to conceptualize this new, conceptualize this new, to improve both in plane and out of plane capacity of peers, both in plane and out of plane capacity of peers, timber, so low carbon footprint, timber, so low carbon energy and seismic retrofit, integrated energy and seismic retrofit, consume less gas to have also in the field, consume less gas to have also in the field less hazard, and then it is removable. This is more. And then it is removable. This is more. This is a very nice concept because these earthquakes in the Netherlands they will stop. So the fact that you are not, you are installing something you are not. It is very. You are installing. I know that 24 minutes very important. I know that 24 minutes. Okay. We different. This is a modular design. Different. This is a modular. You can really design. So basically, you can adjust based on your needs. We adjust based on your needs. But in my opinion, what is more effective? But in my opinion, what is more are these detailed guidelines? Are these detailed guidelines that we they explain step to step how to design? That we they explain step to step how to design this type of retrofit. This is one of the cases where cyclic. This is one of the cases where cyclic tests was super important, or were super important because super important. It is much more easy to understand the mechanical behavior. It is much more easy to understand the mechanical behavior of such a system. If you test system. If you test the element in a quasi element in a for sure quasi shake table test is the then final the shake table test is the final on this topic we are now collaborating with we are now collaborating with the University of Trento for a test held in Patra in the framework of the RIS project Patra the name is Strong Sustainable Timber Retrofit of Concrete Building Strong Sustainable Timber Retrofit of Concrete Building the idea here is to retrofit the idea here is to retrofit the frame as well as the infill and this frame as well as very nice infill and this will be test very nice next test taking place in next within next. Then after the LNEC test where we had the collapse of LNEC test where we had the collapse of it is very interesting but the motion of the roof was not controlled. It is very interesting but the motion of the roof was not controlled of the roof. What if we would have a more rigid roof or less rigid roof? What if we would have a more rigid roof or less rigid roof? And in this framework, let me see because I have to framework. Okay. Let me see because I have to see. We actually propose this test. We actually propose this test again in the framework of in order to project in order to understand the behavior of gables. Try to understand the behavior same motion of gables if subjected to the same motion of in order to top and bottom or different motion in order to characterize this type of component. Not only the acceleration is important, also the not only the acceleration is important, also the drift. Don't tell me how Satya from seismic out of plane how Satya Mesri Gables seismic out of plane response of Mesri Gables came out with Supreme. Ask him because he will be here in June and July. Ask him because he will be here in June and July for this test. Okay, Supreme is on one line. But okay, Supreme is on one line. I don't know why in this presentation. I don't know. We are organizing also a blind prediction contest. We are organizing also a blind prediction contest. So on Bulletin of Electrical Engineering. So it's not a really website. It's a web page if you want. It's not a really website. Uploading the information as soon as we have. So uploading the information as soon as we have. So researcher can actually contribute. Can actually all the data contribute. All the data that you see today are available. All the tests that you see today are available. Service for the vulnerability assessment for the vulnerability estimation coordinated by UCenter, equivalency framework estimation coordinated by UCenter, EPOS European framework of infrastructure, and there is a section for infrastructure, and there is a section for experimental data, and if you the vast majority of our experiment, if you don't find the one, the vast majority of our experiment, if you don't find the one that you are looking for, send me an email and I will. So this sentence is, I want to conclude. So this sentence is much better in Italian, but this sentence is much better in English. Count what is countable. Let's try in English. Measure what is measurable, and what is not measurable. Measure what is measurable, and what is not measurable, and make measurable. As another former student of the school would have said, former student of the school would have said, everything that can be counted does not necessarily count. Everything that can be counted does not necessarily count. Everything that counts cannot necessarily be counted. And what counts to me? I have to thank who created this school. I have to thank who created this Nigel 20 years ago. So Nigel, and I have to thank all the professors, and I have to thank all the researchers, the visiting professors, students, the researchers, the alumni, students, the technicians, the alumni, friends, the roommates, technicians, because without them, roommates would be. Because without them, very different place, and would be a not a 1% place, and not a 1% of today would have been even thinkable without this would have been even thinkable without these environments. Thank you very much. Thank you.
Okay, I will appreciate also the solid foundation, and we have time for one question or two. And we have time for one question or two, if any, from the audience. Yes, please, Paolo. Okay. You. Okay.
Did a great presentation as usual. I have a technical questions. Actually, it's also a curiosity. Actually, it's also a curiosity to say that in regards to the fact that you say that, of course, experimental test and numerical analysis they need to be conducted together. They need to be coming out together to guidelines, coming out with guidelines. But you also did something. But you also did something that you did different. In the sense that you did, and from the simple interpretation of such behavior of mechanical behavior system with food, you just came out with some you just came out without providing carrying out without providing carrying out details like FEM analysis. Why that? When you think is sufficient? Why that? When you think is sufficient to provide some lines, when instead and provide guidelines, and when instead analysis like them also perform detailed analysis like them FEM analysis.
Easy question, thank you. Very easy question. Okay. No, okay. You're right. Theoretically, you're right. I mean, theoretically, all the type of analysis test would be having all the type of analysis. In this specific case, we actually conceptual design of the conceptual retrofit before any test of the retrofit before simply any test. Sit down and say, okay, how this stuff will work. Sit down and say, okay, how this stuff will work. In our opinion, we conducted each psychic test, proving that it was psychic test, and then after that was finally test, and then after that we finally test on the entire full-scale shake table. So, in my opinion, this is a very peculiar case where this is a very peculiar case where the things are really going direction, and you have a simply confirmation that, and you mechanically based confirmation that mechanically based formula is just equilibrium at the end. It's not working rocket science, and this is one working, and this is one of in other context maybe when you have something more complicated, maybe when you have something more complicated, I'm saying that you need something else to prove what you're saying, that you need more something else to prove, you need something to prove that, or you need more tests, I don't know, you need something to prove. We were lucky, they are working. We were lucky.
Thank you very much.
Okay, I would now move further question to the lunch break, and I will thank again Kiko for the lunch break, and I will thank again Kiko for his presentation, and let's move to the next talk, and let's move to the next talk, please, Ali Guneyos Shebe, please, Ali Guneyos Shebe. Okay, you can.
Yes.
I'm okay. You can. Come to the stage. You can. Come to the stage. Whenever ready, we talk about numerical modeling of an Earth, a benchmarking study.
Thank you very much.
Please, the stage is
thank you everybody for being here. Thank you very much. Sharing this moment with us. Today I'm going to talk about modeling in Earth Dam at U Center. And I purposely didn't put my name on the first slide. Because this presentation contains the results of a teamwork. Which has been carried out with the contribution of the following people. Which has been carried out with Carlo Lai and Domenico Gioffre from the University of Carlo Lai and Domenico Barbara Borzi, myself, Antonino, Barbara Borzi, myself, and Francesca from U Center, and all the researchers of U Center, Elisa. We are aiming to provide a set of guidelines for a good practice by using inputs and outputs by using of a project carried out at U Center in terms of with an undisclosed client. With an confidentiality agreement between our clients. Unfortunately, we are not allowed to give any information regarding the dimensions of and we cannot provide colored representations. Those are the terms of confidential. Those are the terms of the confidential. Let us start with the background information. Our dam is located in central Italy. As generic as possible. With a crest height of 9 meters and plan dimension of 45 meters. And it was surprising to see that it is rather unconventional. Core contains only 10% of fines. Contains only 10% of fines, gravel and sand, and actually compacted gravel and sand. The rest part, the remaining parties. Now, the small stream moduli of the nucleus, of the subsoil, and of the shell subsoil, are well characterized. In terms of cross-sol and mass. Similarly, good is always a relative term. Perhaps good is always a relative term. Standard practice in terms of a good amount of standard practice campaign, both in terms of experimental campaign, laboratory tests, in terms of in situ, provide the mechanical properties, deformability, but also the grain composition of the materials. But also the grain composition of the materials, but also the subsoil layers, so let us say that material. Respect to the standards, the data set is complete. If we make an overview of the layers that we are modeling, of the layers that we are modeling, let us start. Shell has a hydroconductivity of 10 to the minus 4 meters per second, and the friction angle more or less sandy. It is more or less a sandy. Nucleus is due to the presence of the fines, although they are low. Due to the presence of the fines, hydroconductivity 100 times. It is lesser hydroconductivity 100 times. With the same friction angle. Due to the with the same friction angle of the friction in the presence of the lower nucleus is more silty. So the friction lower nucleus is more silty, is lower. So the friction angle is lower. Provides the stability. So it has the friction provides the stability 40 degrees. So it has the friction angle. Silty layer is the first layer of the silty layer is the first layer of the natural deposits, and which is followed by the gravel layer, and finally which is followed by the gravel layer, and finally the clay layer. And this is the shear velocity profile that we are going to shear velocity profile that we are going to. Now, the presentation is prepared in terms of analysis going from more simple to more complex, analysis going from more simple to more complex, so step by step. We are starting by the static analysis. We are starting by the static analysis. A staged construction. We followed a staged construction domain in the numerical domain. First phase, actually, initial phase, the phase first phase, actually, initial phase, excavating the soil deposits. Excavating the soil deposits, the insertion of the curtain wall, then the insertion of the curtain wall, followed by the construction of the embankment, followed by the construction of the embankment, and finally filling the reservoir up to 6.50 meters, filling the reservoir up to 6.50 meters, so the operative and conducting static analysis and conducting static analysis equivalent properties, equivalent properties because we cannot use the small string properties. Operative properties in more known terminology. Operative properties in more known terminology. As the first check, the water table location. As the first check, the water table location, formed after the step 3 surface shown, formed after the step 3, is compared blindly. Is compared blindly with an independent solution provided by the client. With an independent solution provided by the client, the comparison comes out quite convincing. Also by here we see the solution that is less accurate. Here we see the solution that is less accurate solution provided by the client based on the infiltration solution. Static analysis based on infiltration of the groundwater level. Infiltration of the groundwater level. The second benchmarking study is actually comparing the vertical displacements. Actually comparing the vertical displacements on the location of the embankment, top of the crest, on the location of the after the construction, of course, after luckily we have, of course, after less amount of clay layers. We have so we less amount of clay layers worried about, so we don't have to be worried about. So by providing the measured oidometric conditions and by providing standards and by providing standards of operating factors we could actually model with a good consistency, with a good consistency, the vertical displacement due to construction, the vertical displacement due to construction, which is calculated of the crest top, which is calculated 4 centimeters, versus measured 8.5 centimeters, versus measured 8.5. So this brings us to. Linear dynamic analysis. Still we are not linear dynamic. First we need to resolve the issues non-linear. First we need to resolve the issues in the linear domain. Now, the first thing first is that we need to set up a proper boundary conditions. We need to set up minimize boundary conditions to minimize the reflections. Unwanted reflections in the model, increase the accuracy of the model. So what are those boundaries? Those boundaries are, what are those boundaries? Free-field boundaries. Those boundaries are which actually provides a fictitious, fictitious, so that they damp out all of the reflections, that they damp out all of the reflections that are different from the response of those that are different from the response of those 1D. And at the base an absorbent boundary condition, and at the base an absorbent boundary condition, which should reflections prevent from reflections from the base, reflections from the base back into the model. Then we need to check also the is it capable of the grid propagating the seismic waves? In this case, our grid is perhaps already too fit. Our grid is perhaps already too fit because in nonlinear domain we need to even capture the strain localization and everything like that. To capture the strain localization and everything like that. Going to 30 hertz, 10 hertz is good enough to model like a rule of thumb. 10 hertz in non-linear domain, like a rule of thumb. And finally, due to the 2D nature of the we are providing a two-component horizontal on vertical, provided in terms of shear and vertical, provided in terms of shear and absorbing boundary at the level of the absorbing condition. Base of the model condition. The base of the model. Now here comes the third benchmark of our work. Now, before even going to earthquake motions, complex earthquake motions, numerical model in the linear domain by the use of a Ricker linear domain. This is an important passage because this is an important output visible. The output find visible. We can see also by eye in time domain. We can see also by eye in time domain interference, reflections, first arrivals, interference, and we checked our response of our code with an independent one of software with an independent one since it is linear. Which provides actually since it is linear. In this case, we use the code of strata. In this case, we use the code of Strata, the University of Texas, developed by the University of Texas, tau tier within the ambient of the. And we can see that actually the overlap between. I forgot to tell, but we are now comparing the response of the flag model. We are now comparing the response of the flag model. It should give the nearby column response. It should give the 1D column close as possible. And apart from few spikes and few inconsistencies like that, which are due to inconsistencies like that, which are due to actually the presence, small reflections from them, due to small amount of reflections from them, due to small amount of Rayleigh damping. The correspondence is actually outstanding. The correspondence shows us that outstanding. The numerical grid model is well set. The numerical grid model is well set motions to propagate the real earthquake motions. Now, this slide and the next slide are interrelated, so I couldn't decide which one to put first. I decided because in any case we need to put the ground motions based on the amplification characteristics of them, and we need to use the input motions and we need to use the input motions to compute the amplification functions. Let us take into granted that we selected seven motions. We selected seven motions of horizontal and vertical components, and we analyzed of horizontal and vertical components, and we analyzed instead of the Ricker wavelets, we applied the real earthquake ground motions. And let us see how the amplification characteristics of the domain. How do they like? Let us start from the more classical one. Let us start from the soil surface versus the rock outcrop. The soil surface versus the rock outcrop. So B versus C. We can see that, it is under them, so we are applying a very small Rayleigh damping, so we shouldn't be really concerned of these parts, so let us focus on those. Soil layers have the first natural frequencies of about 2 Hz, which is actually slightly amplified by the presence of the dam. Slightly amplified by the presence of the dam. Less closer to 2, and it becomes less closer to 2, and it becomes slightly further replicated. The first natural frequency. The motions already amplified by the first mode of the underlying soil layers. The same thing is also happening for the second fundamental. The same thing is also happening for the second, which is actually this time amplified much. Which is actually this time amplified much prevalent because this is closer to the because this is closer vibration frequency of the dam. Which appears to be 6.4 actually. Which appears to be 6.4 is the real frequency of the embankment. Is the real frequency of the embankment. Which tail of the amplification function affects this tail of the amplification function affects so our system amplifies 4.2. So our system amplifies 4.2 and 6.4 hertz more prevalently. As I was mentioning, this slide was this slide was so was related to why I selected input motions. Why I selected input motions is the ambient of the ambient of the environment of the dams. We can be more flexible in this case. We can be more flexible. So why I selected input motions? We used a rather narrow band spectral compatibility. We used a rather narrow band spectral compatibility with respect to the uniform. And we air forces covering all the fundamental frequencies. Air forces covering all the fundamental frequencies of the dam itself. 2 times of the frequency of the dam itself. Sorry, period of the dam itself. Period of the dam. Now, let us see what is happening in the model. Now, let us see what is happening in the model. They are accumulated. Let us see the strains where they are accumulated. They become how much still in the linear domain. Still in the linear domain. Using the same linear viscoelastic model. Using the same linear viscoelastic model that we discussed maximum in the linear deformation or maximum linear deformation or calculated maximum linear strain are calculated and stored for each grid inside the here it is quite interesting to see that actually here it is quite interesting to see that actually this is linear wave propagation linear wave propagation a direct outcome of a linear wave propagation wave propagation in this environment. We see that the presence of this environment increases the strain demand. Increases the strain demand right below the dam. So right below the why this is happening? Right below the dam. So why this is happening? This is due to the because the increased deformation is due to the constant downgoing waves. So here they create a constructive interference. So here they create a constructive deformation demand. And they further amplify the deformation demand. It would be rather normal to expect that. It would be rather normal to expect that a sort of nonlinearity. Those deformations will be even more pronounced. Those deformations will be even more pronounced. And this is actually a representative distribution of the logarithm of the gamma max over 2. So it is defined in terms of log. Now, this brings us to the modeling of the nonlinear. This brings us to the modeling of the nonlinear part of the problem. First thing first, by using the already available data and the available information and the available information in the literature models. We calibrate our hysteretic linear viscoelastic there also. Soils are not linear viscoelastic there. When they exceed a certain, they start to show nonlinearity. They start to show nonlinearity. Those models, and then we set up by using those models, information gathered here, by using the maximum information gathered here, by using the maximum deformation expected, even further passing it, maybe even further passing it. So here we show an example. For the silty layer, and here we are showing the silty layer, and here we are showing an example for the nucleus itself. Let us see what is actually happening inside. Let us see what is actually happening inside the numerical analysis. What is happening? We can see the formation of 2 to 3. It depends on the intensity, 2 to 3. It depends on the intensity, 2 to 3 shear failure surface motion. 2 to 3 shear failure surface. Second one is always this one, and third one. Second one is this. Usually this one, and third one. And due to the presence of actually the larger ones, we see a prevalently horizontal displacement. We see a prevalently of the soil blocks displacement. So they are separating of the soil blocks. left one going to left and right one going to right. Left one going to left and as a consequence, the crest is settling. As a consequence, because there are no more supports supporting the crest. Because there are no more supports. And finally, due to all this, strong nonlinearities, we are losing strong nonlinearities. Horizontal. We are losing the amplification characteristics of the amplification characteristics of the in the linear domain. We are de-amplifying the acceleration time histories. We are de-amplifying the acceleration time histories at the crest level. We can see the same information in terms of profiles. We can see the same information we are having 1, 2, 3, 4, 5, 6 profiles right now. 1, 2, 3, 4, 5, 6 profiles right now. And now we are having a look at the maximum horizontal acceleration. The peak of the acceleration time histories. The peak of the acceleration time histories. Acceleration time histories. Let us focus on the tree. It's most interesting in terms of the DEM body. Most interesting in terms of the DEM body. So rather expectedly, we are increasing. So rather expectedly, still amplifying the input current motion. Still amplifying the input current motion. And this de-amplification is actually happening. And this de-amplification is actually happening just because of this. Just because of this interrelation between the response of settling and everything is correlated. Settling and everything is correlated. And we note in this time we should focus on the fourth profile. In this time we should focus on the fourth profile, which is the displacement. So there is a low amount of displacement. So there is a low after an earthquake. If we want to after an earthquake, if we want to operable without any becomes still operable without any. And in this case, it's 13 centimeters were somehow acceptable. 13 centimeters were somehow acceptable. And we see them like a mean displacement. And we see them like a mean displacement on the fourth profile over there. On the fourth profile over there. Now, is this 13 centimeter? Can we really believe in this 13 centimeter? Can we really believe in this 13 centimeters or not? Now we are focusing on Newmark type of analysis. Now we are focusing sliding block type of analysis, and we are taking sliding block type of analysis. And we are taking the acceleration time history, of course, of this. Let me correct myself. Just below the sliding surface. Just below the sliding surface. At this point of interest, at this, and then we are applying a constant acceleration. Then we are applying a constant acceleration that could yield or the crest, we can say, or the and then we simply calculate the Newmark sliding. And then we simply calculate the Newmark sliding block type of computation. And when we consider this, when we compare 13 centimeter revisions versus the 15 centimeter, we can confidently say that we can start believing. We can confidently say that we can start believing in the results of numerical simulations. Up to here, all of the slides show more or less all of the slides show the more or less a standard good set of practice for there are some what-ifs analysis. So there are some what-ifs. What would happen? First, what-if? Different input motion suite, which is actually less demanding. Motion suite. So, which is actually less demanding. Should we really use the uniform hazard spectrum or not? Uniform hazard spectrum by using. So we question this, which is this time like a Baker type condition, which is this time like a Baker which we condition to 0.2 hertz, which we condition to 0.2 hertz, not 4.2, not 6.4 peaks, but in the middle, not 4.2, not 6.4, but in the middle. And we compared our results in terms of mean. And we compared our results in terms of mean, ones that we obtained by using the ones that we obtained by using the UHS type results of compatibility. Results are striking. While we are finding like 12 centimeters or 13 centimeters, like 12 centimeters or 13 centimeters of horizontal displacement and 15 centimeters in terms of horizontal displacement and 15 centimeters, which is still compatible in terms of spectral compatibility, but less compatible in terms of spectral compatibility, but less strict. We are halving all the seismic. So the question, are we imposing a criterion that is too strict? Are we imposing a criterion that is too strict? It should be investigated furthermore. It should be investigated furthermore. The second question is that what would happen if we consider ground instability? What would happen if we considered ground instability, soil liquefaction? Now we are investigating the consequences of the soil liquefaction to reduce the consequences of the soil liquefaction to reduce use of a loosely coupled model. The data set unfortunately was not permitting us to use a more sophisticated tool where we model everything together, more reliable model where we model everything together, more reliable. This actually brings back to the discussion of the data set. Brings back to the discussion of the data set. The data set should have been actually calibrate better. A fully calibrate better. A fully. If we use this very simple but effective model, we can see that effective model. We can see that left-hand side we see our classical left-hand side we see our classical model. And the right-hand side, we are using the. And the right-hand side, we are using the. But we implemented some sort of. But we implemented some sort of. So by linking the shear deformations, enforced model to create excessive enforced model to create excessive water pressures. We are now seeing here that, and we are now seeing here that. I'm apologizing. This 2 to 0.5% gamma. I'm apologizing. This should be. We are further amplifying almost by the shear strain demands, and all of the deformation bands are thicker. More obvious. Deformation bands are thicker, more obvious, more visible. And consequently, the increase of the horizontal and vertical displacement and vertical displacement of 50 to 60% are in the order of 50. This is actually more critical than the first point. So this is actually more critical. The use of soil liquefaction models must become in terms of must, in terms of requirements, also in terms of guidelines, or even code provisions. Guidelines. They must become a must, code provisions, and furthermore, they must become a must. At least a well characterized, well done, a well penetration testing is necessary. To use the penetration testing is necessary to use the more sophisticated tools. This must be a must without any question. This must be a must without any question. So this brings me to the final slide of the conclusive remarks. A series of static and dynamic analysis of an earth benchmark is presented, including the formation of the phreatic surface, static displacement model, static displacement model, wave transmission checks and dynamic slope displacement demand comparison. Furthermore, it's noted that the use of a less demanding lessen the displacement demands up to 50 to 60%, which is actually somehow compensated by the presence of the seismic liquefaction, which increase with the same amount. So I tried to make this presentation took this simple argument and presented this, just thinking that what if I were a student, like to listen if I were a student, transmit my message, and it will be my pleasure to receive your questions for further discussion.
Thank you very much. We have certainly time for questions or discussion. Is there any? Roberto, please.
Okay, thank you, Ali, for your presentation. Let me say, a couple of questions. One refers to one of your last comments. Less demanding input ground motion. Less demanding input ground motion. I am rather skeptical about especially for this type of application, why using 0.2 why using 0.2 all in all, this is related to long duration. Pointed out that the accumulation of displacement is a duration. I would rather use conditional aspect that is related to long periods rather than short periods, rather than The second question, this is how to deal with the uncertainty of the shear stress parameters, because again, shear stress parameters, because again, incapacity failures of the slope is essentially very much whether the friction angle is 33 degrees or friction angle is 36 degrees. So this is another matter of major uncertainty. So this is another matter of major uncertainty.
Thank you very much, Professor Paolucci. So the first comment, thank you very much, Professor Paolucci. So the first comment, there are two aspects. The first thing is the initiation of the displacement. The first thing is the initiation of the related to the amplification characteristics, which should be related to the amplification characteristics. Displacement may not start to initiate. Displacement may not. But after the first yield, first formation of the. But after the first yield, first formation of the. I agree with you on the fact that. I agree with you on the fact that on the long period should be perhaps another constraint in order to try to capture the development of the seismic displacements of the seismic displacements. However, using uniform hazard input motion based off maybe input motion. Maybe a little bit too safe, still a bit too safe. A little bit too safe. Fixing another period at long period content, fixing another period at long period content, and two loci maybe a better. With two loci maybe a better. For the second data set this time. For the second data set this time, we were lucky to have a data set well characterized in terms of standard well characterized in terms of standard a good set of direct shear tests and we had a good set of direct shear tests under conditions, and a good set of unconsolidated undrained type of tests, unconsolidated undrained type of tests about laboratory strength parameters. So we were sure about in case of uncertainty of the strength parameters. But in case of uncertainty of the strength parameters. To be done, or using the lower bound to be done, or using the lower bound, or more than one, or carrying out a set of more than ones to provide the output, to provide what would be expected with lower bound, what would be expected with lower bound predictions. But according to my experience, the data set of this work, according to my experience, the data set was the best. Unfortunately, in terms of standard analysis, it was not allowing for us to calibrate the liquefaction model. It was not allowing for us to calibrate the liquefaction model, set up the standards, allowing us to fully set up the standard models.
Okay, are there other questions or comments? Well, I have a very brief one. I think the following slide you mentioned the use of modeling the liquefaction because you said that there was. Can you elaborate a little bit more on that, on the choice? Can you elaborate a little bit more on that?
Yes, what we had was the information. What we had was the information that we was only the presence of the relative density. So this relative density, we used the standard brine, which was actually linking the fin brine, which was a shear type of deformation to the volumetric shear type of deformation, and it can be set up by just inputting the relative. And it can be set up by just inputting the relative. But a continuous CPT profile, we would have easily used the PM4 we would have easily used the PM4 worldwide, which is not only models a part of the liquefaction, not only models a part of the liquefaction dilation peaks, but also provides deformability, dilation peaks, and loss of strength and rigidity with the number of cycles. Loss of strength and rigidity with the number of cycles. We couldn't play with this model. Unfortunately, we couldn't play with this model.
Okay, thank you very much. And with this, I would close this session. Let's thank again for the lunch presentation. Let's thank again both the speakers And the session will start again with the keynote lecture at 2:30 here. Thank you.